Welcome to the Health AI Brief, breaking down the AI shaping our world one concept at a time. In the last episode, we defined artificial intelligence, or AI, as the broad goal of creating technology that mimics human cognitive functions, like seeing or understanding language. We called it the big toolbox, but today we're looking inside that toolbox at arguably the most important tool of all, machine learning. So what's the difference? I think the clearest way to think about it is that AI is the destination and machine learning is the vehicle getting us there. An AI system is the whole product you interact with. It can be built with many parts. Some parts might be simple, like human written rules and logic, like if this lab value is X, then flag it. But the part that learns from experience, the part that gives these tools their power and adaptability, that's machine learning. It's a specific method for achieving AI where instead of giving the computer a huge list of explicit instructions, we allow it to learn the patterns for itself from data. So the models we see in medicine today are built on a powerful principle that you can remember as train, detect, predict. Firstly, a model's trained on vast amounts of data. Then through this training, it learns to detect incredibly complex patterns within that data. It then uses those learned patterns to make predictions on new and unseen data. So train, detect, predict. Let's illustrate this train, detect, predict framework with two very different examples that fit this single definition. First, consider a machine learning system designed to detect diabetic retinopathy. Here, the model is trained by being shown thousands or even millions of retinal scans that have been labelled by experts as either healthy or showing retinopathy. Through this training, it learns to detect the specific visual patterns, things like microaneurysms, hemorrhages, exudates, that signal the disease being present, even if they're ones that we humans don't know of at all. It learns itself rather than being explicitly instructed what to look for. Finally, we then show the model a new unlabeled scan, and it uses those learned patterns to predict the likelihood that the patient has diabetic retinopathy. Now let's apply that same three-part thinking to large language models, or LLMs, that generate clinic notes. These models have been trained on a vast library of text, a huge portion of the internet, books and articles. From this, it learns to detect the incredibly complex patterns of human language, grammar, context, syntax, and how ideas logically connect. And then when it listens to a conversation between a doctor and a patient, it then uses those patterns to predict the most likely sequence of words that would accurately summarize the conversation in the format of a structured medical note. So you see, whether it's finding patterns in pixels or patterns in prose, the underlying principle is identical. A model is trained on data to detect patterns and make a prediction. So while AI is a broad system that might contain both human instructions and learned abilities, machine learning is specifically the part that learns the patterns without explicit human instruction. So why does this distinction matter as a clinician? Because I think knowing that the engine is machine learning gives you the right questions to ask. It focuses your critical appraisal on that train, detect, predict model. When you encounter any new machine learning tool, you can ask some very specific important questions about it. First, with regards to training, the most important question is what data is it trained on? For the retinopathy AI, were the images from a population that matches yours? For the language model, was it trained on generic web text or high-quality verified medical notes? The source and quality of the training data is the single biggest determinant of its reliability. Second, with regards to detection and pattern detection, ask, did the patterns it learned apply to my specific situation? If an AI was trained to spot fractures on adults, the patterns it knows might not apply to subtle green stick fractures of a child. Its world is defined entirely by the training data. It can only see what was in its training data. And third, the reliability of predictions. How good are its predictions? This is where we must think about failure. So how many false positives does it generate? How many false negatives does it miss? For language models, this includes the unique failure mode of hallucination, where the model predicts a plausible sounding but entirely fabricated detail. Understanding how tools fail is the key to using them safely. To recap, AI is the broad field, machine learning is the powerful engine within it that works by being trained on data to detect patterns and make predictions. Understanding this engine is your key to evaluating these new tools safely and responsibly. That's all for today. If you found this useful, then don't forget to like and subscribe so you don't miss future episodes.